we're going to continue with exponents, but now we're looking at exponents that have fractions. So I call them fractional exponents. Now these fractional exponents, we don't ever use the word fractional exponents, we just use the words radicals. So we are looking basically at radicals, but I wanted to highlight fractional exponents just so that you remember. If you take a look over here, you can see the fraction. It is an exponent, 1 over a number, which we say 1 over n. And whatever we're dividing by, 1 over 2, well, then the 2 would go here. Or if it was 1 over 3, then the 3 would go there. That will make more sense as we do some examples, so don't worry about that. First, when we see this half, that tells us, okay, we're dealing with a fractional exponent or a radical, and so we would write 25. Maybe I'll move it over. Oh, I forgot about that. That just moves it over. So we have 25. And we have to have our square root symbol, different from a division symbol. And the number out in front here is the denominator, which is a 2. Now, whenever it's a 2, we just don't write it. So really, this is the square root of 25. Now, we should know what that is. We can evaluate it over on the right here. The square root of 25 is just 5. So we're trying to find out, I think we learned in maybe a previous unit or a previous year, square root of 25, you can break that down into 5 times 5, a prime factor tree, and there's a pair of 5s that can come on out, so you would write that on the outside, and on the inside is nothing, we've taken it all, so it's just going to be a 5. So that's why the square root of 25, which you should have memorized, is just a 5. So let's take a look at B. We have a negative symbol on the outside, but the half only is going towards the number on here, the base, the 25. It does not affect the negative symbol. Whereas if you look at C, the half affects the 25 and the negative symbol. So those ones are different. So here we've got the half. So I'm going to write the half by starting to write that. And what are we looking at a half of? Well, 25, it's not the half of 25, but the root 25, and then we can have this negative symbol on the outside. Now, we don't actually have to write that 2. In fact, we don't ever write the 2. So this is just the square root of 25, but negative. So the answer, square root of 25 is 5, and then we have our negative. So this negative symbol is kind of like it's on the outside there, but we don't need to write the brackets. Now compare that to here. The square root of negative 25. So now the negative symbol is on the inside. And you can tell because sure enough, it's on the inside. It's inside the brackets. So we need to, again, not write the 2. I'm not going to write that. Just going to write the square root of negative 25. And we need to evaluate it. Now, I don't know why for this one here, it's negative 5. I didn't write it though. For some reason, I just wrote it right here. I'll just erase that. The square root of 25 is 5, and then we have the negative. And the square root of negative 25. So if you were making a tree and you need to split it up, but it's a negative, the idea is negative 5 times 5. The idea would be pull out the pairs, but I can't pull them out. They're completely different. One's a negative 5, one's a positive 5. In fact, you should know that you can't take the square root of a negative number. So when I write here the square root of negative 25, and we actually have to evaluate that, we have to say, well, it's impossible. We can't take the square root of a negative number because you can't pull out a pair. So maybe let's write that here. There's no pairs. Now, let's keep going. We have 8 to the power of a third. So here we'll write the 3, and then we'll put the 8. Now, if you have forgotten, maybe I'll write it off to the side here. The cube root of 8. If you were to do this, you would need a tree. So 4 times 2, and the 4 can break down to 2 times 2. Pull down that. And because it's a cube root, we're not looking for pairs, we're looking for triples. Sure enough, I do have a triple right there. So the answer is 2, and then you write your leftovers on the inside. However, there is nothing left over, so our answer is just 2. And sure enough, if you think about it, 2 times 2 times 2, 2 times 2 is 4, times 2 again would be 8. So the cube root of 8, which number? 3 of them. Which number, if it was 3 times, would get you 8? Well, the answer would be 2. Whoops, I need to write that over here. So we write the cube root of 8. Which triple was it? Well, it's a triple of 2. Now, let's continue on. And now we've got the cube root of 8 again, but we've got this negative on the outside. And I don't think there's anything left for me to do here to evaluate it. I know what the cube root of 8 is. You should know what that is as well. I just did it. The answer is 2, but there's a negative on the outside. So the answer is going to be negative 2. Cube root of 8, yeah, would be 2, and the negatives on the outside. Now, you compare that to here. So if I had to write it in radical form, you have to put the cube root of, and all of it, negative 8. So then, remember the square root. I wasn't able to do the square root of negative 25 because if I broke down 25, one of them is negative 5, one of them is a positive 5. I can't get a pair. It's impossible. I can never do it. You can't take the square root of a negative number. But now we've got the cube root. So now I got to make a tree here. So let's go negative 4 times 2. And this can become a negative 2 times 2, and I can bring down the 2. And so you think, well, I can't take out a triple because one of them is negative, but 2 of them is positive. However, if I make them all negative, now I have 3 negatives, and a negative times a negative times a negative, there's 3 of them, is still negative 8. So I am good. Negative 2 times negative 2 times negative 2 does equal negative 8. So I've made this tree, and this tree does get you negative 8. And do I have triples? Yes, I do. So my answer is negative 2. So you can take a cube root of a negative number because we will have just an odd number of them. An odd number of negatives will still be negative. So we can make a little note here. It's impossible to do a square root of a negative number, but it is possible to do a cube root of a negative number. So I can't do that, but I can do the cube root of a negative number. So that's good. You're going to just kind of have to have that memorized. So that's it for here. You need to know how to write these in radical form and then evaluate them. And then keep in the back of your mind, when is there a negative on the outside? So in this case, it's B and E. And when is there a negative on the inside? Because when there's a negative on the inside, it's sometimes impossible, and sometimes it's not. So yeah, sometimes it's possible, sometimes it's impossible. So keep that in mind. And if it's on the outside, well, you could always have a negative on the outside. So we're going to do this. We're going to make it a little bit more complex down below here. But this is a good intro to all of this.